this channel under Physics Practical Theory and the Teaching Methodology. So today we are presenting the electricity practical concerning the potentiometer. Our potentiometer today is locally made. With this experiment, we have been given a potentiometer wire, a wire of resistance R, a meter rule. We have given connecting wires. We have given two dry cells as a source. We have given a switch, resistance box, galvanometer, a center zero galvanometer, and a cell together with a jockey. The aim of this experiment is to determine the internal resistance of this cell and the EMF of the cell. How is it? Before that, the circuit have been arranged according to the circuit diagram which have been given from this figure. So, the question said that while the switch is closed, set the resistance R is equal to 1 ohm, then record the value of balanced length L. The circuit is closed, then R is equal to 1 ohm, then find the balanced length. Okay. So we are determining the balancing length by considering the centered zero galvanometer, the reading on the centered zero galvanometer. Okay. So first reading I have 26.2. Remember that the length of the sun is equal to 80 centimeter according to the question. Okay. After then, the question said that repeat the procedure in C for the values of R equal to 2 ohms, 3 ohms, 5 ohms, 10 and 10 ohms. So we are repeating the procedure above, but this time R is equal to 2 ohms. Okay. For 2 ohms, okay. Now my reading is 31.5. Okay. The procedure is repeated, but now R is equal to 3 ohms. This is 1 ohm, this is the 2 ohms, so together is 3 ohms. Again, I'm determining the balancing point. Okay, now it is 34.0. After 3 ohms, let us find the 5 ohms. 5 ohms is here. Okay. For the case of 5 ohms, we determine the balancing point. Okay, according to my reading here, it is 36.2. After 5 ohms, let us find the 10 ohms. Okay, at 10 ohms I have 39.5. So these are my readings. I'm going to make a data analysis. After data analysis, then answer the required questions. Okay, so after obtaining the results, here is my table of results. Table of results, taking the row which contains the physical quantities with the respective units, and the row which containing the values which have been determined. After table of results, the graph which is added from the table of results can be shown in this one. The question will say that plot a graph of 1 over L versus of 1 over R, hence determine the slope and the value of 1 over L intercept. So this is the graph. The graph has a heading with the respective unit. Scales which have been used, it's 0.5 in vertical axis, 0.5 times 10 power negative 2 in vertical axis. In horizontal axis, the scale is 0.1 per ohms. So this is my nature of the graph. Remember to indicate the slope. Slope indication is very important. Also the best fit line. As you can see, my graph have been taken, almost all the points have been taken by the graph. Remember to extend the lines, the vertical line and horizontal line, and show the direction vector. After then, the question said that from the results obtained in part 2, determine the EMF and the internal resistance of a cell E. This is cell E. Assume the value of power supply is 3 volts. Okay. So how can I determine the internal resistance and the EMF of a cell? What you need here is to determine the equation which is governing this graph. Okay. So first of all, let's determine this. Okay. Part 2 was saying that determine the slope and the 1 over L intercept. So slope of a graph can be determined. Slope can be determined by taking the change in 1 over L dividing by the change in 1 over R, which is equal to, at this point, this is 4, as you can see here directly, 4.0 minus, lower point here is 3.0, but here it is times 10 power negative 2 divided by, this point here is 1.1 minus this point here, this is 4.1, 0.41, sorry, 0.41 per centimeter, per ohms. Okay, so here I have 1 times 10 power negative 2, this is per centimeter, dividing by 0.69 per ohms. This gives us 0.014 ohms per centimeter. Okay, so this is the value of a slope. After then, 1 over L intercept. So 1 over L intercept you can read here directly from the graph. At this point, this is 2.45 times 10 power negative 2. This is per centimeter. So after obtaining the slope and the 1 over L intercept, the question said that find the internal resistance and the EMF of a cell, whereby the power supply is equal to 3 volts. Okay, so from the equation of the circuit formula gives us I is equal to R plus R small. Call it equation 1. But also, The potential drop due to resistance is given by IR. V is equal to IR according to Ohm's law. So after having the two equations, let us divide equation 1 and 2. So by dividing 1 by 2, it gives us E over V is equal to I into bracket R plus R small dividing by IR. This gives us R plus R small dividing by R, which is equal to 1 plus R small dividing by R. But we have been drawn the graph of 1 over L and 1 over R. So we need to determine that equation. But EMF of a cell is directly proportional to the original length. But the potential drop is directly proportional to the balancing length L. So if we keep the constant and remove the proportionality sign, we have given as E is equal to KLO, call it equation 3, and also V is equal to KL, call it equation 4. By taking equation 3 dividing by equation 4, here it gives us E over V is equal to KLO divided by KL, which is equal to LO divided by L. So means that E over V is equal to LO over L. So we can substitute this one into the equation above. So then, this implies that LO dividing by L is equal to 1 plus R dividing by R. We are going to make 1 over L a subject. So divided by LO both sides of the equation. Here we have 1 over L is equal to 1 over LO into bracket 1 plus R dividing by R. So 1 over L is equal to 1 over LO is equal to plus R dividing by LO multiplying by 1 over R. If we can rearrange this equation, it gives us 1 over L is equal to R dividing by LO. Out of the bracket, we have 1 over R plus 1 over LO. So this, if we can compare this with the linear equation, mxc plus c. So this is the value of c, intercept. This is the value of a slope, where this is the value of y. Okay. So from there, we can determine the internal resistance of a cell. So from slope,